Hello my dear students, let us discuss JEE Advanced 2025 chemistry questions here. So here I have brought two questions from Electrochemistry from JEE Advanced 2025 paper. Okay, so we have one question in JEE Advanced paper 1 and another one is in paper 2. Let us discuss both of these questions here. So the question saying here, an electrochemical cell is fueled by combustion of butane at 1 bar and 298 Kelvin. Its cell potential is given like this, x by f into 10 power 3 joules, where f is the Faraday constant. Okay, the value of x here. So this is the value of x which we require to find here, and they also given this Gibbs free energy data for formation of the products like CO2, water from the butane. So this data also they given. By using this data we need to find the answer. So now what we required here, its cell potential we required to find, right? That is what the value x they mention. So in order to get that, so we have a relation between Gibbs free energy delta G naught equals to minus NF E naught cell. So E naught cell is what? Cell potential here, that is what we require to find. So what is N here? So number of electrons participated during this chemical reaction. Okay, this combustion process now. So we need to write that combustion process. Therefore we can get this N value and this delta G naught value, right? So by substituting that we can get this E naught cell of this particular reaction. Hope it is clear. So let us find this. In order to find, let us write butane C4H10, okay, plus O2 combustion giving us 4CO2 plus 5H2. That's it now. This is the equation which is forming, right? Now write the structure of butane here. So I can write CH3, CH2, CH2, CH3. This is the structure of butane. So for these terminal carbons, what is the oxidation states we have? So for these 3 hydrogen atoms are attached. We know hydrogen electronegativity is lesser than the carbon. So hydrogens will be having +1 for each hydrogen. So minus 1 for like with respect to each carbon, each hydrogen, minus 1 for each this carbon. So there are 3 hydrogens, so it will be -3. So for this side also it is -3, and for these 2 carbons it is -2, -2. Hope it is clear how we are giving the oxidation states for each of these carbon. Now here these carbons are completely converted into carbon dioxide, which is having +4 oxidation state. Therefore whenever we have -3 carbon, -3 oxidation carbon converting into +4, how many electrons are participating in the reaction? So -3 to +4, so total 7 electrons now. So for each carbon 7 electrons, this carbon, this terminal and this terminal. So there are 2 carbons with -3, so 2 carbons, each one having 7 electrons are participating. So 2 7s are 14 electrons are participating with respect to these 2 terminal carbons. For these 2 carbons, -2 is converting into +4. So -2 to +4, it means 6 electrons are participating, okay, and 2 carbons are there now. So into 2, so 12 electrons. So totally for 4 carbons, this 14 plus 12, total 16 electrons are total 14 plus 12, total 26 electrons are participating in this chemical process, in this combustion process, in this oxidation process, right? So 14 plus 12, so total N value is 26. Hope it is clear how we got this N value. Now what is the required thing we need to find? So we got N value, we require now this delta G naught. So delta G naught of reaction, how can we write? Delta G naught of reaction equals to, see they have given the formation data delta GF, it means formation of CO2, delta G naught formation of water is mentioned here, right? And for butane also they mention. So whenever formations are given, so what we require to do? So delta GF products minus delta G formation of reactants, right? Products minus reactants we need to take. So 4 into, what is the product? 4 CO2, now 4 into delta G naught F of CO2 plus 5 into delta G naught F of water, okay. So these are the products formed, minus what is the reactants here we have? Butane now. So take minus how many butanes we have? 1, right? So 1 delta G F naught of butane, and you know we can write here the oxygen also, but there is no use of writing here because standard Gibbs free energy for any element in its standard state will be considered to be 0. Therefore, this value will becomes 0. So, no need of worrying about this delta G naught of O2. Okay. Hope the remaining values we can put here and finally we will get some answer here. Okay. So, what we can do here, 4 into for delta G F of CO2 is how much? Minus 394 plus 5 into how much? Minus 237. Okay. So, minus of minus 18 we have. So, here we will get kilojoules. Okay. So, because units are mentioned as kilojoules, right. So, now finally what we are going to get here, delta G naught reaction will be how much? So, 16, 36 plus 1 7, 37, 3 remaining 12 plus 3 15. So, minus 1576 and this one plus not minus. So, here minus is there, that is why minus. So, 7 35 3 15 18 we have and 1 10 11 we can write plus 18 I am writing. So, kilojoules. Okay, we can write like this. Okay. So, after this how much we have here? So, minus 11 1 6. Okay. So, 1 again 6 7 we have and 2 we have plus 18 we have. So, this is the kilojoule we have, and the next by simplifying this how much we are going to get? So, 18 means 11 3. Okay. So, here we have 5 minus 1 4. Okay. Then next here we have 7 2 with minus kilojoules. Okay. So, this is a delta G naught of reaction we have. Hope it is clear how we have simplified this, right. So, I am explaining everything very clearly with very basic understanding way, right. So, we have delta G naught and now we have delta this N value. So, just substitute that values over here in the given formula. In that first formula whatever we have written, delta G naught we have written it as delta G naught equals to minus NF E naught cell we have written now. Yes. So, substitute the values which we have. So, here we have minus 2, what is the value we have? We have 2743, 2743. Okay. So, this is the value in terms of kilojoules we have, and here also we have minus N value how much we got? It is 26, right. And F we know Faraday's, okay, what is that? 96500 coulombs, right. Into here E naught cell, in the question they mentioned it as x by F into 10 power 3 joules. This is what they have mentioned in the question, right. So, by simplifying this, see here negative sign, here negative sign you can remove, and we know this F means what? They mentioned F is Faraday's constant, it means 96500 we have to take. So, 743 kilojoules I am writing as it is. Okay, this side we have 26 96500 coulomb into x by F means 96500, they told it as constant. So, I am writing 96500 into 10 power 3 joules. Okay. So, this number and this number getting cancelled. Okay. So, now what we are remaining with? 2743 kilojoules equals to 26 into, see here we have x into 10 power 3. Okay. So, coulomb into volt, what is that? Coulomb volt. So, coulomb into volt is joules. So, I am writing here joules. Okay. So, here we have 10 power 3 now. So, 10 power 3 we can write, instead of writing 10 power 3 I can write it as kilo. So, what we have here? Kilojoules, here also kilojoules. So, both units are getting cancelled out. So, here we are remaining with x. So, x is equals to 2743 divided by 26, right. So, by simplifying this we will be getting around 105.5. So, this is our answer for this particular question. Hope everything went very smoothly now. So, I hope you really like the content. Just click on the like button if you really like the content. Okay. Let us discuss one more question here. Yeah. So, in this question an electrochemical cell is given. In that dichromate ions in acidic medium reduced to Cr plus 3. So, just remove this part, maybe printing mistake here. So, now the current that flows through the cell for 48.25 minutes to produce 1 mole of chromium plus 3. Yeah. So it means Cr2O7 2 minus we have. So this is converting into, this is reducing to Cr plus 3. Yes. So if you write normal reaction, it will be, so 2 Cr2 is there now, so we will getting like this. So here oxidation state is plus 6. I hope you know how to find the oxidation state. Let us consider we have 2 carbons here, chromiums here, each one has X, 7 oxygens are there, 7 into minus 2, because oxygen is divalent, so which is electronegative, so minus 2 for each oxygen, so 7 into minus 2, and overall charge is equals to the total charge. Here we have minus 2. Yes. So we will be getting, so minus 14, if we send this side, it becomes plus 14 minus 2, it means plus 12 by 2. So it will be 6. That's why I have written here 6. Hope it is clear. Now I am removing this simple thing, right? So now plus 6 is converting into plus 3. It means what is the change? So 6 to 3. So 3 change is 3. Reduced number is 3. So for 2 chromiums now, so 3 into 2, it will be 6. So number of electrons change, that is n factor is 6. Now look into the question once. So what they are saying, to produce 1 mole of chromium, this is producing 2 moles of chromium, right? But we required 1 mole. So 1 mole means I can say, so this is for 2 moles. If I want to take for 1 mole, just divide this equation by 2. So it means it becomes 3. So n factor is how much now? 3. Hope it is clear up to here. Now see, this is the ion which is depositing, this is the ion which is forming. So now we have from Faraday's law, the quantity of a substance deposited at an electrode is directly proportional to the quantity of charge passed through the electrolytic solution, right? So now weight, I am writing it as weight equals proportional to Q means charge. Charge I can write current into charge I into T. Now I am removing this proportionality constant and I am replacing with something called Z, the electrochemical equivalent here. So which is equals to I into T. Okay. So now we can further simplify this. So weight equals to, so Z means electrochemical equivalent, which is having equivalent weight by Faraday's. This is what we can write. Z means what? Z is nothing but equivalent weight by Faraday's. Okay, we will study all these formulas in the electrochemistry Faraday's laws now. So from there I am writing this. So Z I am writing I into T. So this is how I am giving you basic understanding here. Okay. So they are saying, so now we have got this now. So in this produce chromium, 1 mole of chromium. Okay. So reduce it to the current. Okay, that flows through the cell minutes. So now, so weight by equivalent weight equals to what I can write, I into T by F. I can write it like this. Okay. So now we need to find this I value here. The remaining things we have. See here number of equivalents we got, weight by equivalent weight. See number of moles means weight by molecular weight we are writing, gram molecular weight we are writing. Okay. Similar to that we have gram equivalent numbers or number of equivalents, that is what, weight by equivalent weight. Okay. So weight by equivalent weight means gram equivalent number, which we can also write as n into n factor. Okay. Which is equals to I into T by F. Okay. So from this what we required here, I value we required now. So what is the n? So 1 mole of chromium plus 3 now, 1 into, so for 1 mole what is the n factor involved here? 3. Okay. F is how much? 96500. Okay. And what is the time they mentioned? They mentioned it as 48.25. Okay. This is a minutes. So multiply with 60. Therefore it will be in the seconds. Now we are remaining with I here. Okay. So this 3, this is 20. So this 0 cancel. So this will be 1 time, and here we will be getting, so 4825, right? 4825 by 48.25. So this will be 100 times. Okay. So what is our I value? So I will be 100 amps. So this is our final answer. Hope it is clear how we solve this particular question right now. So if you have any confusion, so just write in the comment box. We will discuss about that in detail in the upcoming session. Thank you for watching.